Let us now consider integrating these functions using algebraic substitution. Let's find the integral of dx over x plus 4 divided x plus 4 times square root of x plus 3. So I think it's quite obvious that we should be setting our z to be equal to square root of x plus 3. So with that, we have z squared is equal to x plus 3. So x is equal to z squared minus 3 and dx equal to 2z dz. We can now apply that substitution. So we have dx is 2z dz over x plus 4. So that would be z squared minus 3 plus 4. Square root of x plus 3 is z. So we can cancel out z. And we will be having the integral of 2 dz all over z squared plus 1. So we have 2 integral of dz over z squared plus 1. So the integral of du over a squared plus u squared is 1 over a arctangent of u over a plus c. So therefore, the integral of this expression is 2 times 1 over 1 arctangent of u over a. So z over 1 plus c. So this is equal to 2 inverse tangent or arctangent of z square root of x plus 3 plus c. So this would serve as our final answer. For our next example, let us consider square root of 4 plus square root of x dx. So we set z to be equal to square root of x. So z squared is x and dx is equal to 2z dz. So we now have the integral of the square root of 4 plus square root of x is z and dx is 2z dz. So we now have the integral of 2 z square root of z plus 4 dz. We can now apply another substitution. So for our second substitution, we can let u be equal to the square root of z plus 4. So this would be u squared is equal to z plus 4. So z is u squared minus 4. And dz is 2u du. With that, we can now apply the substitution. So we have 2 integral of z, which is u squared minus 4. And square root of z plus 4 is u. And dz is 2u du. So we have 2 integral of 2u squared times u squared minus 4 du. So this would be 4 integral of u to the 4th minus 4u squared du. So this would be 4 u to the 5th over 5 minus 4 u cubed over 3 plus c. So this would give us 4 over 5 u to the 5th minus 16. So 4 times 4, 16 over 3. 16 over 3 u cubed plus c. We can factor out u. So we have 4 over 5 u to the 4th minus 16 over 3 u squared plus c. We factored out u so that we can rewrite this one as square root of u. So u is square root of z plus 4. And then the LCD is 15. So 15 divided by 5 is 3. 3 times 4 is 12. U to the 4th minus 15 divided by 3 is 5. 5 times 16 is 80. U squared plus c. So we have square root of z, square root of x plus 4. And then we have 12 u. U is the square root of z. Z is the square root of x, and then plus 4 to the 4th minus 80 square root of x plus 4 squared all over 15 plus c. So we have the square root of x plus 4 times. So we can remove the radical. 4 over 2 is 2. So we have 12 times square root of x plus 4 squared minus 80 square root of x plus 4 all over 15 plus c. For our third problem, let us consider 5x minus 1 square root of x plus 2 dx. So we can let your z be equal to square root of x plus 2. So z squared is x plus 2. So x is z squared minus 2. And dx is 2z dz. So we have the integral of 5 times z squared minus 2 minus 1 square root of x plus 2 is z, and dx is 2z dz. So we have 2 integral of z squared, and then we have 5z squared minus 10. 5 times 2 is 10, so minus 10 minus 1, so minus 11 dz. Can we check whether we have considered all the terms? So 5, and then x is z squared minus 2, so that's 5z squared minus 10. Minus 1, so minus 11. 2 times z is 2z squared. So we have 2 integral of 5 z to the 4th minus 11 z squared dz. So this is now equal to 2 times z to the 5th over 5 minus 11 z cubed over 3 times 2 plus c. So we factor out a z, and then the LCD is 15. So 15 divided by 5 is 3. So we have 3z to the fourth. Minus 15 divided by 3 is 5. So minus 55 z squared plus c. So we have 2z, 2 square root of x plus 2 times 3 z squared. So that would be square root of x plus 2 to the fourth minus 55 times z squared is x plus 2 all over 15 plus c. So this would be 2 square root of x plus 2 times 3. So 4 over 2 is squared. So we have x squared plus 4x plus 4 minus 55x minus 110 all over 15 plus c. So 2 square root of x plus 2 So we have 3x squared plus 12 minus 55. So I think it would be negative 43x. And then 12 minus 110. So minus 98 all over 15 plus c. Next, let's have this. Integral of e to the 2x dx over square root of e to the x minus 1. So we can let your z to be equal to the square root of e to the x minus 1. So z squared is equal to e raised to x minus 1. So e raised to x is z squared plus 1. E to the x dx is equal to 2z dz. Or 2z dz, correct. So dx is equal to 2z dz over e to the x. So dx is equal to 2z dz over z squared plus 1. With that, we can substitute that here. E to the x is, so we have e to the x squared dx all over square root of e to the x minus 1. So e to the x is z squared plus 1 squared times dx 2z dz over z squared plus 1. So we cancel out one of those z squared plus 1. And then the denominator is z. So we can also cancel out to this one. So we have the integral of z squared plus 1 times 2 dz. So we have 2 z cubed over 3 plus z plus c. So we have 2z times z squared over 3 plus 1 plus c. So that would be 2z times LCD is 3. So we have z squared plus 3 plus c. So we have 2. Z is the square root of e to the x minus 1 times the quantity z squared. Z squared is e raised to x minus 1 plus 3 over 3 plus c. So we have 2 square root of e raised to x minus 1 times 1/3 e raised to x plus 2 plus c. Next, let's consider this dy over square root of y plus 4 minus 2. So we can let your z be equal to square root of y plus 4. So z squared is y plus 4. So y is z squared minus 4. dy is 2z dz. So we have the integral of dy 2z dz all over square root of y plus 4 is z and then minus 2. So we can divide 2z by z minus 2. So we have 2z minus 4. So we have 4. So this is equal to 2 plus 4 over z minus 2 dz. The integral of 2 dz is 2z plus 4 ln of z minus 2 plus c. So we have 2. Z is the square root of y plus 4 ln of square root of y plus 4 minus 2 plus c. For our last example, let us consider the integral of x raised to 1/3 minus x raised to 1/4 dx over 4x raised to 1/2. So we are checking the indices 3, 4, and 2, and the LCM of which is 12. So we have x is z raised to 12. So dx is 12 z raised to 11 dz. So this would be the integral of x. So that is z to the 12 raised to 1/3 minus z raised to 12 raised to 1/4 all over 4x z raised to 12 raised to 1/2 dx. dx is 12 z raised to 11 dz. So we have the integral of z raised to 12 over 3 is 4 minus z 12 over 4 is 3. 4 z raised to 6 times 12 z raised to 11 dz. Z raised to 11 divided by Z raised to 6. So we have Z raised to 5. So we have 12 over 4 is 3. Z raised to 9 minus 12 over 4 is 3. Z raised to 8 dz. So we have 3 over 10 Z raised to 10 minus 3 over 9 Z raised to 9 plus C. Substituting it back, Z is equal to X raised to 1 over 12. So 3 over 10, X raised to 1 over 12 raised to 10 minus 1/3 X raised to 1 over 12 raised to 9 plus C. So we have 3 over 10 X raised to 5 over 6 minus 1/3 X raised to 3/4 plus C. And that would be our final answer.